Hi, my name is Mike and I'm an Esri instructor, and today I'd like to show you how you can georeference imagery you may obtain over the internet. So here we're looking at an ArcGIS Pro project, and in this map I see there's a JPEG file that represents a NOAA nautical chart that I've downloaded from NOAA's website. It's not georeferenced and we need to assign coordinate systems to it. I'd like to also point out to you this map is represented using the NAD 83 state plane coordinate system for Maryland. It's in US feet. Also notice here we see the name of that JPEG file. Again, it's showing that it's presently unknown as its coordinate system. So let's get busy and georeference this. So you'll see there under the Imagery tab a number of tools on the ribbon available to work with, including one that's grayed out presently called Georeference. If I select my JPEG and zoom into it, that Georeference tool becomes active, and I can now see where this nautical chart is represented here on land. It's actually far to the west of the Chesapeake Bay area in Maryland. So what I'd like to do now is work with this Georeference button. And this will open up the Georeference tab and include a number of tools on the ribbon. Among them is the ability for us to add control points. So as I select this button, I'm now able to establish a from point here on this nautical chart, which I'm going to do as I zoom in closer to a prominent physical feature. This is Point Lookout State Park here in Maryland. So as I zoom in closer and the chart redisplays, I'm now able to place the from point to create a link that will be used to associate its location for this pixel to another point on the base map. So I'd like to locate Point Lookout State Park, and using the locate tool, I can now type the search keyword for Point Lookout and find it listed in this dropdown. This will place a feature on my base map that will be used as reference, taking me to Point Lookout. And as I zoom in closer now to this image, I can now place a corresponding to point to create a link for this nautical chart to now shift and align itself to. So as this chart redisplays, you'll notice that it's going to be placed approximately in the proper location, but I need to create a couple of other control points using some other physical features. So as I zoom into a second peninsula, I'll see another prominent location found here that I'll establish another from point. As I turn off, as I zoom out of this chart, I can now zoom and pan to the corresponding peninsula found here on the base map, and then establish the to point for that location. So now you'll see this nautical chart will again redisplay and come closer to where it needs to be, but I think we can go a little bit better. So I have two established control points. I'm going to zoom to this location on my chart where I see a road network, an intersection that I'd like to point out and create a third control point. So as the chart finishes displaying, I'll create a from point. I'm going to turn off this image to see the underlying base map below, and then assign the corresponding to point. And with that, we now have three control points of this nautical chart, and what we've effectively done is known as a first order polynomial transformation. So with three control points, we've now told the software how to shift, rotate, and scale this chart. I'm going to now ask the software to do a second and then later third order polynomial so as we can take into account the actual shape and curvature of the Earth's surface. So working with this control point table button, I can now see listed those three control points that I've just created, what their coordinates are, whether or not they have residual error values, and as you see at this time, they do not. But as I add additional points, you're going to see those error values appear. Now that I've added 7 control points to this chart, you'll notice the residual X and Y error amounts that represent the distance from where you've established a control point to where the software believes that point should be. Now these numbers look good. I'm using a first order polynomial. Notice the improvement though when we switch over to using a second order polynomial. I think we can get even better with more control points and a third order. Let's find out. I've now created 11 control points, and you can see how they're evenly spread across this image, and the residual values listed here are pretty good. Again, this is working with a second order polynomial. Notice the improvement though once we go to a third order polynomial, these error values are reduced, and we have what's known as a rubber sheeting effect. Notice the bending and stretching of this image, taking into account the location of those control points and the curvature of the Earth's surface. It's at this time I could now save this work, and once that's done, the next time I bring this image in, it will know how to properly represent on the Earth's surface. Now that you've learned the principles of rubber sheeting to georeference your imagery, give it a try yourself and see how it goes. I hope you've enjoyed this video.